Okay, so networking, and we're just going to discuss the OSI model, which is kind of not really it's a framework that people more talk about than computers actually use, but it's a good model to follow. But the idea, if you're like new to networking, would be, and this is an example in our textbook. Suppose we had a person who speaks English, who looks like a Buddhist, but he speaks English, and wants to send a message. The message is, I like rabbits. Wants to send a message to a person who only speaks French. Okay? And this person only speaks English. And this person is in a building, and this person is in a different building. So, this person happens to work in the same building with a person who speaks English and Dutch. I think the author of our textbook is Dutch. Maybe that's why Dutch was chosen. So this person speaks English and Dutch. This person speaks English. And this person speaks French only. But he works with somebody who speaks French and Dutch. So now the question is, how can this person get this message over to this person? How can an English-speaking person get it to the French-speaking person? They don't speak the common language, but this person can say the message in English and this person could understand it in Dutch. Then write the message out in Dutch. Maybe even attach something to the message saying this is in Dutch. And then if this person can send the message to this person can understand it and then convert it back to French. But now this person doesn't have a way to send it to this person, but she happens to work at a building where there's somebody else who has a fax machine. You guys know what a fax machine is? Okay. I don't know if this technology's gone now. But anyway, so you can send a paper message over telephone lines. So this person can put the message in Dutch and even put a note on top of it saying this is in Dutch, so that when he gets to another building, they'll know who to give it to. Gives it to this person. Now, this person doesn't speak Dutch at all, so if this message is screwed up, this person doesn't know it. They're just going to add a fax number to it and send it to a fax machine. The fax machine gets sent over to this building, and there's a person here who doesn't understand Dutch, but receives fax messages. And the message could even have a fax number if the person wanted to send a reply, so you can send that fax number. And then this message says it's in Dutch, so this person knows to give it to this person, because this person speaks Dutch. Then this person gets the message and says, oh, it needs to be translated from Dutch to French. This person translates it to French and gives the message to this person, and this person now can read the message. Okay. So this is, it's kind of an interesting example of how to get a message from one person to another, where as the message is being propagated around, different tasks are doing different jobs, and each task has a corresponding person at the other building. So, for example, suppose this person wrote out the message in Dutch, but this is like, I don't know, incorrect Dutch. Maybe there's two kinds of Dutch, like people from the north. People from Holland speak one way, and people from Aruba speak a different kind of Dutch. But suppose there was something wrong with the Dutch part of the message, and it gets to this person, and this person can't understand it. This person shouldn't be calling this person and say, hey, your message is no good. This person needs to speak to this person to correct any problem. If the message was faxed from this person to this person, and let's say the paper got jammed and the paper got all screwed up, this person shouldn't be calling this person to say, hey, the paper and fax machine, you need to send it again, or calling this person. This person should call this person and correct any problems. So at each step along the way, sometimes they call this a stack, any problems at any level have to really go back to the same level on the other side. So sometimes they call these, sometimes they call this a stack, and sometimes they call this a layering system, where you have a message, then you take the message and you put kind of like another message on top of the message, and then you pass it to another, you go down the stack, and then they put a fax number on top of the language on top of the message, and then you transmit it over. And then on this side, you start peeling off the headers and bringing it up till its final destination. So you kind of get that idea. And we kind of do the same thing with messaging. Messaging, sending a message from one computer to another. And there's no people, there's no translating or any fax machines like that, but we may have a message. We're trying to send a message from one person, or from one application to another application. And we might find on our computer, maybe you're on your computer and you're doing many things at once. You have Chrome up and Internet Explorer up, and you're running several programs, and different programs are talking to different machines. So you might have a message that's on one of your applications that you need to send to another machine. So you have to put like a header on it to say where it's going. Then it might be, as it goes over the internet, it might be maybe your message is so big it can't be sent as one message. Maybe it has to be broken up into several messages. So that might be something like if you ever bought a dining room set, you might get like a table and 4 chairs. And when they deliver it to you, they may put it all in one box. Or they may send you 5 boxes. Like one box with the table and then one box with each chair. Maybe they'll take 2 chairs and put that in one box. Maybe you get 3 boxes. A table, and then 2 chairs in one box, 2 chairs in another. So this message, which might have some information in it about like what program on this machine is trying to connect to what program on this machine. And then the message is so big, maybe it's like a movie, a bunch of pictures. It might be so big, it needs to be broken up into separate boxes. And then when it eventually gets transmitted, kind of like the fax machine, it's going to get transmitted over the internet, and right behind the message is going to be another message from a different machine, and maybe we'd have to put something on the end. So you might see something along the lines of a header, that's what the H is for. We put a header in front of the message. Then maybe it gets broken up into 2 messages. So here's header level 3, and then it's taking this message and taking part of it. The header and half of the message goes here. And then the remaining part of the message, like message part 2, goes here, and you have another header. And now this piece and this piece get set separately. Now, it would be the job of this level on the other side to collect both messages and realize it has to put it together and make one message for the receiver. So there might be instructions in here, the header 3 and the header 3. This might say, this is, might have a message identifier and say this is part 1, and here's a message identifier and say this is part 2. So that at this level, they could put the message back together. We'll have instructions like that. And then before we send it over some actual communication lines like a telephone or fax machine, we might want to put a new header on it that gives information just how to travel across the fax machine, not really any information about the message. And we might want to put something at the very end. This is a tail. So this is header level 2 and a tail of level 2. Just so when the message comes out, we can read the end of it and go, okay, this is where the message ends. Anything after that belongs to a totally separate message. So this piece and this piece kind of get a level 2, a header and a tail, a header and a tail, and then they get sent over. They get received at the other machine, and the headers and the tails can be taken off. Then at this level, maybe they get packaged back into one message. And then the question is like, why would you go from one message to this message? So we talked earlier in the semester about like encryption. Maybe this is an encrypted version of the message, and in here, in the header, it might tell us what the encryption algorithm is, or what the key is to unencrypt it. And then we unencrypt it and then send the message up to the next level. Okay, so this is just like if you were inventing your own, if you were going to invent your own protocol. your own stack to get the message to go eventually send over and then come back up to its receiver. So at each point, kind of like in our example earlier, we said there was like an English-speaking person and then a person who understood English and Dutch. Well, there have to be an interface. Each level has to take its message, and generally in networking, we're going to call a function that converts our message into the format the level below it needs to know. So instead of talking to a person and saying, here's English, and what is it in French, we'll probably call a function supplied by the operating system, and it will create the message for us. Then this we'll call another method. So this is just kind of a diagram saying that we have these levels. Let's say we had a 5-level protocol. Each level has an interface between them. You go through the levels, then you eventually send the message over, and then they work their way back up. Okay. So when you're sending a message over the internet, let's say this is you over here, and you're trying to connect to Facebook. So you're going to bring up a web browser, let's say Chrome. You bring up a web browser, and in the top you say http://www.facebook.com. You hit enter. You are sending a message out of your computer. The message, it's not too common now, but used to be computers were connected to telephone lines. You guys remember getting those AOL discs in the mail, and you plug it in and you can connect to the internet over the phone? No?
Dial-up connections.
What's that?
Dial-up connections.
Yeah, dial. Is that still around? To dial up through the phone?
I guess just 1%.
Oh, okay. So they used to send these discs, and I remember keeping the cases. The cases when you'd throw the disc out and you keep the case. But they would, every month I would get a new one in there. But anyway, so if you're connecting, let's say, through telephone lines, so then U.S. government, probably back in the 80s, made all the telephone companies connect through a point of presence, which would connect all telephone-connected devices to the internet. So going to a regional internet service provider. And then inside of here would be routers that are connecting data together. So maybe later on in the course we'll talk about what's inside a router. So now a regional ISP would be connected to the internet backbone, which is where all the routers connect to each other. And then through an NAP, a network access point, we can connect the internet to, again, another regional ISP. And then let's say one of these servers is Facebook server. So you're sending a message from your computer through the internet to Facebook server. And we'll talk, in a later lecture, sometimes you send a message, like when you send somebody an email, you send them a message, you don't even care if they get it. You just send it. You don't get a reply saying, yes, I got it. But when you go to connect to Facebook, you're sending a message to a web server saying, I would like a page, and the page comes back, and then you see it. You see it on your screen. And then you log in, username, password, you hit enter, you send another message. They verify your password, and if they know who you are, they say, welcome, your name. They send the message back to you. So you keep going back and forth to each other. So in order to do that, there's several layers of what you're doing. So first step you do, you bring up your web browser, you bring up Chrome. Chrome's an application. You type HTTP, that's now a protocol. What machine are you talking to and how do you want to talk to it? So hypertext transmission protocol would mean I'm asking for a web page from a machine, from a program that's running on this machine that returns web pages to anybody who asks for it. When the page comes back, I would like it to be shown in my Chrome application. So have you guys ever had, like logged into, let's say, Facebook with Chrome, and then you bring up another browser, like Internet Explorer, and you go to Facebook? Would you be logged in? No? Okay, but if you brought up another version of Chrome, then you would be logged in.
Yes.
And the reason is, even though this machine is talking to this server, it's talking to it on Chrome, not Internet Explorer. So if you went to Internet Explorer, it considers it a different conversation. And the difference between those two is one of the layers didn't identify itself. So one of the layers is saying, I'm Chrome. And one of the layers is saying, I'm Internet Explorer, and that's why they would treat it different. Okay. So the OSI stack, and this is really a judgment call. How many layers do you want? The more layers you have, really the more headers you have to put on the message, and you have to pass it to the next level. So the more layers, the slower it is, but maybe the more layers, the easier it is to debug a connection problem. Okay, so just we'll kind of go over this quickly, and then maybe we'll chat about each layer. But there's the application layer. So the application layer could be like Chrome and maybe going to Facebook. The presentation layer would be, depending on the data that comes back. Well, yeah, like I said, we'll go over each layer in a little more detail in a second. Well, the presentation might be, if it's a movie, it'll play a movie player, or a picture, it'll show it. Instead of just getting bits of zeros and ones, it'll show it as a picture. At the session layer, that would be like your Chrome browser is talking to a particular process on the Facebook server that is dedicated to talking just to you, not to other people. So this is your browser talking to a certain program. The transport layer, the next more vague layer, as you go down, it gets more and more vague. This is basically saying your computer is connected to this Facebook server. That's kind of like a machine-to-machine level. Then below that, we're going to start getting into maybe Facebook is sending you a movie and it's so big it needs to break up into little pieces. So at the network layer, we might break up your message into several pieces. And we'll put a header and a tail on it, because at this point is where we're sending it out. We could then package, these would be kind of at the packet level, and this would be at the frame level, and the frame encapsulates the packet. So we'd end up putting another header and a tail on it for this level. And then eventually we'll send it, depending on how we're going to send it. Are we sending the message, are we sending the message over telephone lines? Are we sending it over undersea cable? The transmission method we're saying. And the path of how we get to the Facebook server. We want to report information about the path. If we're going to have a dedicated connection, or we're just going to send one message and not get a report. So the path, the physical path, how we get there would be recorded in that header's information. Okay, so yeah, just a little definition on this standard. Like I say, it's not like computers now talk to each other following the standard, but it's a good standard to follow if you wanted to design your own. TCP/IP is the most commonly used one. So again, this is just a collection of layers, and so this is just kind of a snapshot. This is like a little chart that has all the layers. So when we take our test, a lot of the questions, and I almost don't like the idea of testing students on this topic, because nobody's going to memorize all this. You can't expect you to memorize it. So it's going to just ask you, well, does this layer do this, and does this layer do that? And you can just look it up. Look it up on the chart. So a lot of the test questions, the answers are on this chart. So, but yeah, just so kind of, this is just kind of a high-level view of it. But the application level, so, you know, what programs are open and what data is being sent is kind of at the application level. The presentation level is kind of presenting it to a human being, so it's like encryption and decryption is being done. And if the data coming back is JPEGs, we would open up a picture browser to make it look like a picture. It's ASCII data, which is just a way of converting binary numbers into words. Right? So has ASCII come up in any of your classes?
Algorithms.
Do you have to like convert from ASCII to letter, like numbers?
No.
Okay. So that stands for the American Standard Code Information Interchange?
Yeah.
Okay. Okay. And yeah, and that's run by ANSI, the American Standard, the American National Standards Institute. So yeah, so it's just basically codes for, and then you can convert things into letters, so. Does ANSI ever come up in your classes? Is that ever? Remember the old adage, ask ye stupid question, get a stupid answer? No? No? All right. Well, anyway, okay, so this is basically how we can send data. So all data is being sent as zeros and ones, and we'd like to present it in pictures and words and all that kind of stuff. So that conversion is done at the presentation level as it's about to be presented. The session level is like synchronization and the connection between a port, which we talked about earlier in the class, in the course. So if you bring up Chrome, your Chrome application might be assigned a port number, a particular number on your computer. So any messages coming into that Chrome session will actually come into a port number and get routed to that Chrome session. So on your side, it might be a port number. Well, on your side and on Facebook's side, it would be a port number. On your side, it could be a web browser, and on their side, it could be a process serving up web pages. But it's process to process. And then at the transport level, this is now machine to machine. At the network level, so kind of the last three levels is where the data is actually being sent. And one difference, it depends on, like these two levels could be combined into one level. But at the network level, remember we said an individual company could assign IP addresses to their own machines. So any message coming in from the outside, they would run it through a converter. But then each machine could also have a real IP address. So this could be using the real IP address, the MAC address, the real IP address, and this one could be using internal IP address if it wanted to. So it'd just be converting from one to another. So a lot of these layers, it's just converting data from one to the other, like English to Dutch, and then Dutch to a fax machine, sending the data over. And at any point, if there's an error at any one level, the receiving corresponding level would need to correct it. So maybe later on, we don't have enough time to talk about each level, heavily. But one thing we could do just to make sure we get the right message, or just check for errors in our message, we could use tricks like if we send a message, maybe all those numbers of zeros or all the numbers of ones, we can count up how many there are. Let's say we sent a message and we noticed that there's about 1 million ones. Let's say exactly 1 million ones in the message. So we send the message, and then at the very end we put the number 1 million. So the receiver can receive the message, then look at the number 1 million. They can count up how many ones, and if there's exactly 1 million, it doesn't mean it's definitely the right message, but there's a pretty good chance the message came. And if the number of ones does not match the number of ones you think you sent, then you know there's something wrong with the message. And maybe we could say, could you send it again? I think I got the wrong message. So, we could use some little tricks like that. We'll go into more details later on. So as far as putting headers on, headers using the OSI is basically you have data. So you have data that you want to send, let's say to Facebook. They'll put the application will put a header on it, pass it to the next level. The next level will put its own header on it, pass it to the session level. This level will say, I'm a certain port number, and I want to talk to a certain port number on another machine, so we'll put its header on it. Then the transport layer puts data about, so this is, in this one, in the session header, we're saying which program on my machine wants to talk to which program on another machine. The transport header is my machine address compared to the other machine address. And now the last three letters are where we're actually preparing to send the data. So here we would put a network layer header and also a tail. I thought this graphic was a little odd. The tail is usually very, very small. data-wise. And then the same thing with the data link letter, where we're using the MAC address, puts another header on, puts a tail on. Could also be at the network level, this could get split into many messages. And inside the header, it might say part 1, part 2, part 3. And send it out. And then there's information about the physical letter, how it will actually get sent, whether it's like digital, electronic messages, switch to optical networks, and of course an optical network. And then, like I say, on the receiving side, if there's any error along the way, the corresponding level should correctly either detect it and ask for new data, or it could be the type of transmission. You don't care if it gets there or not. You don't want to report back. So there'll be information inside each of the headers that tell us what to do in that case. And this is pretty much the same picture, just kind of cleaned up a little bit. Just the headers and the tails. Okay. Okay, so yeah, so just look through each of the layers. So we'll go from the lowest layer to the highest layer. So the physical layer is actually connecting the, how the bits are being set. So Ethernet or RS-232 are pretty popular, and also ATM, asynchronous transfer mode, are protocols that are used in the physical layer. The next highest layer is the data link layer. This layer, data packets are encoded and decoded into bits, so sometimes we'll call frames. So it's really broken up into two parts: the media access control level, the MAC level, and then the logical link level. So again, this is the packaging of packets into frames and sending them across transmission lines. So most popular one is the 802, or the 802 series. I was going to say 802.5, but the whole 802 series, coming from the IEEE popular data link protocols. Okay, and then the network level, like we said, was the packet level. So this could be the level where we start splitting it up into small, split a message up into small pieces. So this layer provides switching and routing technology and creating physical paths and logical paths. So the path from one machine to another machine. And then if sometimes the message wants to, depending on what type of messages we're sending, we might want to send all the message along the same path. Other times you might not care what path. Well, that might be for synchronization. You want it to be in a certain order. It could also be you don't care if they take the same path. If you cut them up into smaller pieces, they could arrive out of order, and then the receiver will just wait till they get all the pieces before they start assembling it back together. So if synchronization doesn't matter, we could take different paths over the internet. Okay. Then the transport level, like we said, is kind of machine to machine, not the program on the machine talking to which program on the machine, but just a machine to machine, a host to host connection. So yeah, so this is basically what is the size of the packets, and then when we send packets, how much time should we allow? If there's a response to come, how much time should we allow before we say fails? I think, did somebody hit during the test, when we took the online test, did you hit a page not found or something? Anyone hit that? A few students hit that. Nobody hit that? Nobody? In our class, nobody? No. Students in my other class did. So in other words, like an hour and a half into the test, they went to like see the next question, and the page didn't get generated fast enough, and that browser ran out of time. Like it sent a message, started a timer, and the answer didn't come back fast enough, so they had to close the browser and start over. Well, that's good. It didn't happen in this class. It was because it's the networks class. Okay. So yeah, so then, so as far as machine-to-machine connection, TCP and UDP, which Well, kind of when we talked about TCP, we kind of covered that. TCP is a connection between two programs going back and forth. UDP would be more like when you're sending mail. You're just sending something. You hope it gets to where it's going, but you're not expecting an immediate reply. And if it doesn't get to where it's going, maybe they'll send a message saying, hey, this mail failed, or the email address is no good. So this is just different styles of connections between two machines. So when a message is being built, like when you send a message to Facebook, it's assumed you want an answer back. So they're going to send it using the TCP protocol, which is one where there's a two-way conversation. And if you're just sending a text message to a friend, it would send it on the UDP protocol. Okay, then the session layer is where stuff like your particular, you bring up Chrome and you're speaking to a process on Facebook's server, and it is connected to you, and variables with like session variables will be set, like you're logged in and what your first name is and last. As you bounce around from page to page, they'll get a session variable off the server that says whatever your first name is, and it'll put your name on top of the page. Yeah, so this is the layer that establishes, manages, and terminates the connection between applications. So when you hit log off, when you're on Facebook, you're sending a message saying, I would like this connection now to be dropped. And that data is put inside the header of the session layer. Okay. Okay, then the presentation layer, this is where we're kind of taking the data and converting it into something like a human being could understand. So for example, if the message is coming back encrypted, we would need to decrypt it before we display it to the user. So again, stuff like, coding for how to turn numbers into letters, because human beings read letters, like words being sent. Picture files, other picture file, movie files. Depending on what format the data is in, we would then have applications on our machine that would be able to present the data. And then it gets passed finally up to the application layer, sent to your Chrome browser so you can see the results. And so this would be like, these are applications that are running on your machine, like HTTP, means you're viewing web pages. FTP is file transfer protocol, if you want to send files back and forth from one machine to another machine. Okay, so yeah, and we'll go over, I don't know if we'll spend a whole day on each layer, but maybe we could focus a little bit more, go into a little more detail on each layer. But one thing is, and we've already talked about TCP/IP. There's no rule that says you have to have 7 layers or 5 layers. There's really no right answer. It's kind of a judgment call. But if you were to compare the OSI model to the TCP model, they pretty much map in like at this level. So what TCP calls the application level, OSI kind of calls the application, the presentation, and the session. So basically, from session all the way up to application is kind of like, if using an example, you're using Chrome to connect to Facebook. Whatever's coming into your Chrome application is handled at these 3 levels, and TCP kind of puts that all together in one big level. So you don't have to rip off as many headers to figure out what the next message is. But you have to be able to handle every possible thing that could come in. So again, it's kind of like a judgment call. Machine to machine is pretty much going to exist in any protocol. So if you get a job working for a company that doesn't want to use either one of these and has a better idea of faster transmission, and they want you to design a new one, it's going to be pretty tough to not have this level, the transport level. That's where you're connecting machine to machine. It'd be kind of tough to blend that in with another level. So that'll almost always be its own level. And then networking, that's also kind of pretty tough to skip. That's where You have information about one machine connecting to another machine, and then the network is what path through the internet are they connecting? I guess maybe, since this is information about what machine's connecting to what machine, and this is information about how they're connected, that could get combined into one. And then the actual IP address to IP address and how it's actually connected, TCP actually joined those into one. They call a link and physical buffer. So like I say, it's kind of a judgment call. How many layers do you want? And then if something goes wrong at any point, the more layers you have, maybe the easier it is to find out which layer made the mistake and how to get the message back to that layer. So that's kind of an advantage, having more layers. Okay. So yeah, so when we talked about TCP IP, at the end I said, and here's how it lines, I kind of had a picture like this, and here's how it lines up to OSI, and then we talked about OSI, and then we said here's how it lines up. So there's a big overlap between the two. And it's just good to know what each one is doing, and then realize if you want to, you can combine two layers together. Okay. So any questions about this one or TCP?